data points. It's actually being able to demonstrate the effect, demonstrate a pattern. So I want you to come back to that. Now, for alternating treatment designs, there's going to be an exception. Just hold over to the side that we're going to have an exception. So here we go. Let's take this with reversal designs and how this would work. You're always going to look and you're going to be able to say, do we have 5 data points per phase? Do we have change, 1 change, 2 change, 3 change? Did we formally manipulate the independent variable? When we do, we've got all of those variables. If we only have 3 data points per phase, we're going to accept with reservation, but only if those 3 data points actually demonstrate a convincing pattern. So it's not just the 3 data points, it's whether they actually demonstrate a pattern. The other thing is with multiple baselines, there's a distinction between concurrent and non-concurrent multiple baselines. Who among you can tell me the difference between a concurrent and a non-concurrent multiple baseline?
Come on, guys.
We should know this.
That's a definition from the spot. So concurrent multiple baseline studies, you're looking at the continuous time frame and staggering introduction of the independent variable. But not concurrent, you're looking at different time frames and there's not continuous progression throughout the experiment.
Very good. Very good. Smita is proud of you. All right. Another way to say it. You've got your 4 series. Let's say 4 students that you're studying. In a concurrent, all 4, data point 2 is the same physical day for all 4 students. So time is constant for all members of the series in each study, in the study. In a non-concurrent, you can run subject 1 in January, subject 2 in February, subject 3 in April, subject 4 in May. All right? You will still modify what you've got, but the actual timing differs. In the IES standards, a non-concurrent multiple baseline loses control because the times don't line up, and as such will always be treated as meets with reservation. If you do a non-concurrent multiple baseline, it will never achieve the meets criteria. So I want you to think about that. Here's what that would mean for you. When you write the grant as a concurrent multiple baseline. If you run it, you can run it as a non-concurrent, you can still get it published, but write the grant with it being concurrent, if at all possible, because you want the strongest that you're going to be able to get. All right, now, discrimination. Big deal, this notion of a basic effect. This is actually fundamental to single case methods. A basic effect is the change in the dependent variable across 2 adjacent phases. Basic effect. It's change in the predicted pattern of responding after you manipulate the independent variable. So here's what that says. Take a look at this baseline. You're looking at baseline. The data in baseline describe a pattern. But in single case methods, it's not just that pattern, it's what the next 3 data points will look like. From those data, what is your expectation of the next 3 to 5 data points? If the data in this phase are different than you would have expected, and if that difference is predicted by your logic model, you have demonstrated a basic effect. Now, we're going to come back and talk about how you do that visually. But come on, those of you who are statisticians, you know how to build. You know how to build a growth curve model. You can actually say within confidence intervals, what would the next set of data look like? How far outside of that range do you need to be? Similarly, if you reverse, you now have a new set of data. Now the reason that I want you to be excited about this, think about the importance that is placed on being able to describe the data within a phase as documenting a pattern. And I want you to think about threats to your confidence in the pattern. If you've got trends, if you've got curvilinear models, if you've got high variability, all of those are going to decrease your ability to develop a predictable effect. So a basic effect always looks at two adjacent phases. And because we're saying experimental designs always have at least 3 demonstrations of effect, you will do that at least 3 times. You can do it more, but you'll do it at least 3 times. Now, to be able to say there's an experimental effect, you only say there's an experimental effect if you've got 3 demonstrations of the effect. So one of the things that has been most troubling in a lot of analyses of single case research is many analyses only look at 2-phase conditions. A single case design is identified as documenting a functional relation only when you can demonstrate replication of the effect in 3 different time points. Make sense? Big difference. All right. So when assessing design standards, you're always going to be looking at baseline. You want 5 data points per phase. You want opportunity for at least 3. So let's do it. You ready? We're going to do things quickly now because we only have about 7 minutes. So you're going to look at the baseline, and when you look at the initial basic effect, then you're going to look at the second effect, and you're going to look at the third. So if we were to make that work, let's say, would this design meet with reservation, or not meet? So meet with reservation, not meet. Got it? Okay, ready? 3, 2, 1, show me. Does not meet. You only have 2 demonstrations of the effect. All right, do it again. Take a look carefully. So we've got baseline, intervention X, baseline, intervention Y. 2 different interventions. All right? So meets with reservation, does not meet. 3, 2, 1, does not meet because we didn't replicate. Yes, it went up and down, but come on. We got 2 different interventions. All right, what about this? All right, here we go. Here we go. Ready? 3, 2, 1. No, only 2 data points. Come on. Gear up. What about now? 3, 2, 1. Meets with reservation. But that reservation depends on the power and the consistency of those 3 data points. It's not just if you have 3, it's what they look like. All right? So let's do multiple baseline. Ready? 3, 2, 1. Meets. 3 demonstrations of effect. 3 demonstrations of the effect. What about now? No. All right, but now let's get a little more complicated. So here are 4 series. So does this study, how many demonstrations of effect are possible? Don't look now. You're looking at the data. Don't look at the data. I want you to look at the design. Remember, I want you to look at design first. So part of what I want you to look at, how many demonstrations? So look at the number of data points per phase, number of demonstrations of effect.
Technically, only 2 replications.
So this has 4 demonstrations of effect at 3 points in time. 1 point, 2 point, 3 point. But there are only 4 data points up there, right? So this would meet with reservation. 4 demonstrations of the effect at 3 points in time. You following that? Now, part of what you could say is, well, we want to, how could you make that even more powerful? Well, what about if you did it like this? So now we've got 1, 2, 3, 4, but then we combined a reversal in the last 2 series. Hot dog. So this is 1, 2, 3, 4, 5, 6, 7, 8 demonstrations of the effect at 1, 2, 3, 4, 5 points in time. Make sense? All right. So this would be a strong, this would demonstrate the effect, even though this was a limitation, you actually have strength down there. All right. So alternating treatment designs. The tricky piece, those of you who have done functional analyses, a functional analysis is a process of identifying the variables that affect a targeted behavior. So oftentimes what you do is you identify, let's say, screams. So this is the proportion of screams. And we'd say if he gets attention when he screams, if he escapes a demand when he screams, if he gets food when he screams, if he gets to just keep playing when he screams, right? So does the consequence affect the proportion of opportunities when those things occur? So you look at this, and if you were to look there, what's the most likely variable that maintains screaming? Escaping from demands. All right. But the way in which you actually assess this is, as a research tool, you're always in an alternating treatment design, and this is important, you're always comparing 2 variables. So is escape different than food? Is escape different than attention? Is escape different than play? Make sense? Those are each separate questions. We typically, when you look at food and play, we say there's no difference between food and play. So then we say that we combine them, and we do things like that. But keep in mind, the analysis of an alternating treatment design is always based on the size and consistency of the difference. That's what you're looking at between 2 conditions. And I'm showing you one in which this is the kind of data that you're very common to get from a kid with more significant disabilities. It takes